Assalamu alaikum. Welcome back to my channel Being Physio. Today we are going to see the basic concepts related to acid-base disorders and ABG VBG interpretation. This lecture is very important for all those who are working in ICUs and in emergency departments, and I am going to simplify this concept especially for physiotherapists. So let us start with the basic concepts of acid-base disorders. And our first basic concept is pH. What is pH? Simply saying, this pH has been derived from the Danish word potens dehydrogen. The symbol pH has been derived from this potens dehydrogen, and it means the power of hydrogen ion concentration. Power of hydrogen ion concentration. Yes, pH is represented mathematically as pH is equal to negative log of hydrogen ion concentration. Negative logarithm of hydrogen ion concentration. Or it can also be written as -1 in log of H positive concentration. Or it can also be written as log of H positive concentration raised to power -1. Or simply you can write is it pH is equal to log of 1 by H positive ion concentration. It is because log of m raised to power n. Log of m raised to power n is equal to n log m. So in short, we um, we know pH is inversely proportional to the H positive ion concentration. That means more the H positive ion concentration, lesser is the pH. More the pH, lesser is the H positive ion concentration. You remember this equation, pH is inversely proportional to H positive ion concentration. So this is pH. Our second concept is, you recall the pH scale, basic pH scale, which everybody has read in 11th 12th class. So in that scale, 7 we take as neutral, neutral pH. Water has neutral pH 7, and anything less than 7 is acidic, and anything whose pH is greater than 7, that is alkaline in nature. And if we talk of about human blood, the uh, the normal pH level of human blood is 7.35 to 7.45. Remember this value once for forever. And if there is a person whose pH is less than 7.35, we can say that the patient is having acidosis. If there is a person whose pH is greater than 7.45, you can say that the blood is in alkalosis. So this is the basic normal pH level of human blood. So I'm going to erase this. We are going to cover the basics of acid-base disorders. We have seen what the pH means, and now our second concept is, what is acid? What is acid? Acid is defined as any chemical species or any compound or any substance which has tendency to donate protons. So if there is any substance which donates protons, that means it is an acid. And similarly, any substance which has tendency to accept these protons is base, is the base. For example, I am going to show you HCl plus H2O. It will give H2H3O positive. This is hydronium ion plus Cl negative. This is the acid. This is the acid. And this is the base. This is its conjugate base. It will accept the proton. It has negative charge and it will donate this negative charge to some proton and will form HCl. Similarly, HCl gives H positive plus Cl negative. HCl has donated proton, that means this is an acid. And this chlorine Cl negative, this is its conjugate base. Conjugate base means anything, any chemical species which has the capability, which has the tendency to accept protons. So this is the acid. Now what is acidemia? And similarly, I will show you another example. If there is NaOH, this is the base, sodium hydroxide. It dissociates and gives Na positive plus OH negative. Another definition of base: anything, one is a base is a species which will accept the protons which has been donated by the acid. And another definition, if any chemical species which has tendency when it dissociates in aqueous solution and uh, it donates hydroxyl ions uh, in its aqueous solution, dissociates into hydroxyl ions, that is the base. This is base. So NaOH is a base because it donates OH negative ions. So another concept is what is acidosis? Very important concept. What is acidemia and what is acidosis? These are very two terms, and some people use these terms as synonym of each other, but they are not synonym of each other. Actually, acidemia, whenever you see this suffix emia, emia means wherever you see this suffix amia. Amia means blood. So acidemia means acid blood. Similarly, I will give you another example. Hypoxemia, emia suffix. Hypox means decreased oxygen concentration in blood. This is known as hypoxemia. So uh, this is acidemia. So what is acidemia? Acidemia is state of acidic blood, or it is the state in which blood has abnormally high acid levels in it. Abnor- Abnormal levels of acid in blood. This is acidemia. Now, what is acidosis? What is acidosis? Acidosis is the process. It is the pathological process or the disease which results in acidemia. So acidosis is the pathological state which results in acidemia. For example, DKA, diabetic ketoacidosis. This is the pathological process which will result in decay is the process. It is a type of acidosis, diabetic ketoacidosis, which will result in acidemia. The person will have the his her blood will have the high levels of acids in it. So we can say patient has acidosis, diabetic ketoacidosis, and his blood is acidic. He is having acidemia. So so I'm going to raise this. We are going to see our next concept, that is the normal values of various parameters in blood. So normal values of ABG parameters. First, pH. I have already told you that normal pH is equal to 7.35 to 7.45. This is a number, it has no units. This is the normal pH of human blood. Now, what is the normal level of PaCO2, partial pressure of carbon dioxide in arterial blood? That is equal to, raise this 7.7 point. So your normal PaCO2 level in blood is equal to 35 to 45, 35 to 45 mm of Hg. So this you don't need to remember separately. Simply eliminate 7 point from pH. You will get the value of PaCO2, normal PaCO2. Now, normal level of bicarbonate, normal level of HCO3, that is equal to 22 to 26, and its unit is milli equivalents per liter. 22 to 26 milli equivalents per liter. So now mnemonic. When you see metabolic, whenever you see metabolic, like metabolic acidosis, metabolic alkalosis, always think of bicarbonate. Think of bicarbonate. Whenever you see respiratory, always think of CO2, carbon dioxide. Always think of carbon dioxide. So these are the normal values of parameters in ABG. So we will proceed to the basics of acid-base disorders and compensation. Now, basics of acid-base disorders and compensation. What is compensation? What are basic acid-base disorders? You always remember there are four primary acid-base disorders. Depending on primary disturbance. There is the famous equation. Famous equation is that there and that equation is known as Henderson-Hasselbalch equation. pH is proportional to HCO3 bicarbonate by carbon dioxide. This is the basic equation. This is the relation from Henderson-Hasselbalch equation. So either bicarbonate concentration can change or PaCO, partial pressure of carbon dioxide, can change accordingly. Now, if bicarbonate changes, if the primary disturbance occurs in bicarbonate, if it is HCO3, that changes. So now you recall, when you think of metabolic, it is bicarbonate. The change occurs in bicarbonate. HCO3, it has two basic primary disorders. Bicarbonate gives two primary disorders. That is, when bicarbonate increases, HCO3 increases. This is called metabolic alkalosis. And second, when bicarbonate decreases, this is called metabolic. This is very simple, acidosis. So what is metabolic acidosis? The decrease in the concentration of bicarbonate in blood. So what is metabolic alkalosis? Increase at concentration of bicarbonate. Similarly, we are having PaCO2. So it also has uh, two disturbances. Either it will increase when PaCO2 PaCO2 increases. You see it is respiratory acidosis, or when PaCO2 decreases. So this is respiratory alkalosis. So this is the this is the mm, basics which you have to remember in order to understand the ABG interpretation. How to understand ABG interpretation? So basically, we are having two basic defects, either in bicarbonate, when bicarbonate can increase or decrease. When increases, this is called metabolic alkalosis. When decreases, this is called metabolic acidosis. Similarly, carbon dioxide can increase, this is called a respiratory acidosis, and also carbon dioxide concentration in arterial blood can decrease, this is called a respiratory alkalosis. So anyways, can anybody tell me why increase in carbon dioxide in the blood causes acidosis? Why? What is the relation of carbon dioxide with acid? Why it causes acidosis? Why not alkalosis? No, this is the basic concept you have read in chemistry. Carbon dioxide, CO2. One thing is, there are two concepts, two explanations regarding carbon dioxide being an acid. One is CO2, carbon dioxide combines with water, forms carbonic acid, H2CO3. This is carbonic acid. Carbonic acid is an unstable compound. It soon breaks down in H positive ions plus HCO3 1 negative bicarbonate ions. So more carbon dioxide, more the concentration of carbon dioxide, more the production of carbonic acid, means more H positive ion concentration, and more acidic the blood is. When it increases, means more H positive ion concentration, means lesser is the pH. This is one. Second explanation is carbon dioxide is a Lewis acid. Lewis acid. It behaves as a Lewis acid. So this is another explanation. It has resonance. It creates uh, uh, have a positivity at the carbon atom, because this is less electronegative. It is attached to oxygen atoms. These are more electronegative. Positivity will be created at carbon dioxide, and it will accept lone pair of electrons, and anything which accepts an electron pair is known as Lewis acid, according to the Lewis concept of acid base disorders. So this was a little bit explanation of carbon dioxide being an acid. All this is basics. So you have to remember all this basics. And now our second lecture, that is the interpretation of arterial blood gas analysis. I think this is enough for today. We will meet in another lecture with interpretation of acid base disorders. Hope this is enough for today. Thank you.